But I just said, you can have, GitHub, the YAML files. You can say, anytime I make a change to the tractor, automatically go through and reanimate, generate a new animation on the fly every time I change something.
Yeah, yeah,
It's so crazy that, just the things you can have it do automatically.
yeah, yeah. It's true. It's true. It's amazing now. Hmm.
And, but, just, I don't know, I'm kind of, a lot of the stuff is kind of new to me. So I'm kind of experimenting, but it's kind of like, it's interesting about the house,
Hmm.
and GitHub. I'm thinking of my GitHub brain that, you could have it, you could kind of, have it automatically generate the plans in GitHub, anytime you make a change.
Yeah, yeah.
Uh, so I don't, but I don't know how much, if you're just using straight, uh, Chat GPT and you had a YAML file, I don't know exactly how you process the YAML file. Is there a program that runs that, or is that
Okay,
a,
so that's what I'm describing. I'm saying so.
yeah,
Okay, so let's go through a sample workflow. Um, Wall module. It's got these basic parameters. So the
yeah,
YAML file, the schema, it's essentially a full specification. It
you're
describes
right,
what materials you're using, how you're using, what's the geometry. Now, that's a schema file in YAML. Then you simply say, well, I need to convert that to actual CAD. The YAML is just description. So
right,
so
right,
chat GPT. Hey, provide a compiler, which is another script which would be in Python. It's a
right,
Python script, and compile it into CAD, and it gives you that compiler. So now you feed it the YAML file of, say, whatever the description of whatever you want to compile, and it
right,
compiles it. So it's two pieces of software. Like one is the description,
yeah,
and two is the actual compiler. It kind of it makes sense. It compiles that information into actual geometry and outputs a FreeCAD file. So
right,
that's what it
yeah,
does.
yeah, okay,
Um, so it's just a couple of steps. First you generate. Okay, give me the schema. So you generate a schema for whatever part you're describing. So that could be a wall module, that could be like a plumbing part, it could be a power cube, it could be your joystick. You're designing your joystick, just the graphical,
yeah,
how you're going to 3D print that joystick thing or whatever. It could be anything, and then you just tell it. You tell chat, compile this. Now that's the hard part, because how do you go from a description like that?
yeah,
That's the long, boring, step-by-step thing that now chat is doing for you. It's outputting all that code, and that
yeah.
code just compiles the specific parameters into the bodies, and all the 3D objects. Yeah. So
Uh, yeah. So
I'll do an instructional because this is like so powerful, and I think just anybody could learn it in like in hours. This
yeah,
workflow is doable because you're using the human language. All
right,
you
right.
got to know is, okay, here's the steps you take. Hmm.
Yeah, because like on the tractor, I've just been like prompting it. I'm if I see an error, I'll sit there and talk to it and say, hey, this thing right here is currently like this, and it's incorrect for this reason, and then I'll tell it, try to
Hmm.
tell it again, the correct way it's supposed to be, and
Yeah,
it seems like, yeah,
and I think
sometimes it works. Yeah,
it does work, and sometimes you can confuse chat, and sometimes it gets like it just breaks. But the way to
yeah,
prevent it from breaking, what you want to do is start at each step. So there's one step. Here's all my parts.
yeah,
Here's my assemblies. Here's my final product. So for each of the parts, you define schemas, and then you can generate like literally a part library that, like, if chat starts getting confused, just, okay, chat, don't be stupid. Let me just upload all the parts. Now
yeah,
do this. So
right,
so you can correct, like, if there's some basic error, like it keeps like messing up some part, or like messing up geometry, you just say, okay, here's the parts, arrange them such and such. You can be very clear about how you're defining that. It's all about the clarity. So you
yeah,
break it. Here's the parts. Now give me assemblies. Now, once you have those assemblies, you go through that process again. After you say stabilize this assembly, I've got my frame, the whole frame system. Okay, now I want to add the drive. Okay,
yeah,
frame is stabilized. You might say, well, you might be generating drive parts, like whatever components you got, and keep working that. But you can always go back. okay, chat, here's the schemas. Like if they work for the initial parts, chat can use that. It can handle like a whole bunch of complexity, but you got to kind of define things one step at a time. Mm-hmm.
Yeah, because I was thinking about, one of the things I haven't really looked at yet is the wheels or the tracks
Mm-hmm.
yet, and I was wondering, if I go in and somehow I can make we have the universal track unit
Yeah.
design. I was thinking, how can I, should I go through there part by part and
Well,
just
I would
and
say,
describe it to the AI, or yeah,
yeah, what I would do is, okay, yeah, just break it apart. So it's got the treads,
yeah,
it's got the motors, it's got the sprockets and bearings. You got just define each part by each part. So make yourself a
yeah,
library, and then you can now you got the power. Okay, now modify it to any size, shape, any number of motors, because then you can start playing around. And it only
yeah, because
takes like this.
yeah, if you have a micro track versus a full size life track, everything's going to change.
Yeah, yeah. And that's where you get the big help from
Yeah.
AI, because it can do all that without you having to re-manipulate everything.
Yeah. And then one thing I'm kind of been playing around with the idea is, like for a track, you got to weld certain things certain places.
Yep.
But it'd be interesting to me if we can get AI to generate a 3D printed jig. You could put the parts in a jig that you 3D printed based on
Yeah.
the design, so you could generate new jigs on the fly based on
Oh yeah.
design changes that have been made. So I mean,
I like that.
so I kind of started playing with that, but I haven't gotten too far into it. But
Yeah, because you can say, okay, now you got the geometry. Just say, okay, chat, now just give me a jig that's going to hold all these pieces of metal in this geometry, and
yeah,
we can
yeah,
3D print it if we got a printer of that size, Mm-hmm.
yeah, and you could if you kind of tack weld it and then move on to the next thing or something,
Mm-hmm. Mm-hmm.
But,
Yeah.
yeah.
Let's see. So let me take a look at what you got there in the link.
Oh yeah, and
Let's see. So in the LifeTrac.
yeah, it's funny. Like I had it generate some, like, I thought it was being helpful, and then I'm looking at it. There's 20 different. Let's see.
Let's see. What do we got for any diagrams or pictures? You got any of them there? Preview. So you got some previews.
Let's see here.
Outside of text, do you got any pictures, or I see that's
Here's
a placeholder. Camera feed, okay.
Let's see. It's funny. I saw there's a program that you can just download, on Android called Droid Pad,
Mm-hmm.
and it has a Bluetooth low energy thing standard, and then some of that Arduino hardware has Bluetooth low energy, so you can just use that already existing program phone, and then you can kind of create a new. I guess there's a file, like you have two joysticks, and then you can connect to the Arduino mounted on the tractor, and just connect directly with so we wouldn't have to build any custom hardware per se, but it'd be nice to have a hardware controller, but just as a quick, easy thing, you can use a phone app.
Mm-hmm.
And the built-in
I'm looking at your animation on your log. That's pretty cool. Yeah, yeah. And let's see. Is that how'd you do that? Is that so? That's OpenSCAD generated.
yeah, that's OpenSCAD. You can run animations, and it does it by, like, countdown from 1 to 10, or one, you has a timer on it, and then you can have it. You build into the animation or into the file, where things should be at certain times.
Mm-hmm.
And
how do you get the GIF? How do you make the GIF?
I had AI do it. I just had there's a YAML file, and so every time I make a change, it creates a new GIF and updates it.
Okay.
On the GitHub.
Okay.
So, but that's a standard thing that OpenSCAD outputs. So it just runs like a command line
Mm-hmm.
OpenSCAD on the GitHub server, and
Man.
then automatically outputs it.
So what you've got there, I mean, is just like, okay, the triangles and the loader arms. I mean, that's essentially like if it's headless, it's like all we need. That's like
Yeah,
almost
yeah,
right there.
yeah,
You need some more drive elements, like some shafts and stuff. Um,
yeah.
but
I
that's
mean,
cool.
are you thinking wheels or tracks or
I think wheels, just keep it simple for the first one.
okay,
Just get a high, just because the
yeah,
tracks we'd have to,
it's a lot
troubleshoot
of
that a
work
little
now.
bit, a little
Yeah.
development time. But especially if you could 3D print the like airless tires,
Oh, okay. Yeah, yeah, yeah,
TPU, thermoplastic urethane, that would be cool.
yeah.
Um, let's see. So
And then, did you want to throw a power cube in there, or did you want me
yeah,
to make just like a mount or?
yeah,
Uh,
yeah. So make it so you know the latest on the power cubes. So the absolute cheapest you could ever go is these cheapo 15 horsepower engines.
okay.
And I was gonna do, okay, let's do a mother power cube that's got the reservoir, coolers, the the fans, battery, and to it connect as many of the engine slash pump units as you like. So you
Hmm.
so you have the whole hydraulics in one mother power cube, and babies, which are just engine plus pump.
Oh, okay.
And that way, I mean, the part that goes out is the engine, right?
Right.
The mother power cube is going to be pretty stable. That's just basics. It's just fluid flow components. But the engine pump is the thing you want to be. If you're designing this for easy maintenance, then you want to just snap them in and out. And at 15 horsepower, it's literally that you take it in and out and
Yeah.
unbolt. Ideally, unbolt like one or two bolts. You take that out. You unplug the hoses, and you can replace it or add more power cubes. So I'm thinking like let's just try 15 times 4. How about that?
Okay.
So you got six. I
Yeah.
mean, 60 is functional. That's decent.
Yeah. Yeah.
60
Yeah.
horsepower to get you into industrial duty, um, and then we could add more. So it's like the typical skid steers are going to be your 75. So actually it'll be like 5 power cubes, but we can easily do that and then just keep going. I mean,
Yeah.
at that point you get some pretty serious machines.
All right.
Um, and then like say we got to put on an implement, you know make that additional power unit the engine plus pump. I mean, what's it going to be? Let's take a look at. Okay, I'm going to send you a link. Take a look at the actual engines, the cheapo. I mean, look, right now we're designing for like throw-it, but we gotta have to open source these and at the end of the day, make these so they're lifetime design. Right now we kind of work with what we got.
Yeah.
Simple. Let's see. So the 420 cc's.
Because I mean, I'm kind of just I've got all the space in between the two sidewalls of
Yeah.
so far. We could slide. I can make a
Oh
like
yeah.
a plate. We would just slide them in there. In theory. Uh,
Yeah. So I mean, look at this kind of cheap stuff here. I mean, $280, and you got 15 horsepower. Um,
mhm.
and that's U.S. ship. But yeah, and therefore these are like the easily replaceable units, and just have a whole stash of them so that we can work with. Now the only thing is, it's like it would be nice to take off the fuel tank and just have a common fuel feed from the mother power cube. Think
Yeah,
we can
I
do
see.
that pretty easily?
Interesting.
You got any experience with these? How easy is that to do, or is it they really want their own fuel tank? Because
Uh, yeah, that's a good question.
let's see, because it would have they're carbureted, so you gotta. Where's that carburetor? That's on the side there. So yeah, I think we should be able to take off the fuel tank really easy, because it's like the carburetor is by the black part by the fuel
Yeah,
filter there. So
yeah,
yeah, but yeah, if we do that, so that's the kind of like the simple idea that we can do anytime right now. We've got a lot of experience with these things. Just a
yeah.
simple low cost pump, low cost engine, and you're literally adding. So it's like say 280 plus 100 like $400, and you got for 15 horsepower. I mean, that's pretty good.
Hmm.
Like $25 a horsepower. That's good. Um, so okay, to phase this in, let's do. Can we focus maybe on one like so work out the joystick first. Now remember
Sure.
you we do have that joystick. I never ended up using that for the brick press. No, actually the remote control thing that you did a long time ago.
Yeah, I remember the biggest issue was the lag time on it. It was kind of like you could push forward and you know, you'd be sitting there for a second and then it would lurch
Mm-hmm.
forward. Uh, so I was kind of looking. I was asking ChatGPT, what's the fastest, wireless, method here that we could use, and it's it kind of there's that Bluetooth, because you're standing right next to it. See, if you want to like be like in be in the office, watching remotely, you end up having to go to Wi-Fi, and then you have to put in like a outdoor Wi-Fi antenna or whatever. But then, otherwise you're sitting there with the Bluetooth. Uh,
But what about like what is the simplest way to do it that's got some distance so you can be operating? I mean, you want to make it
yeah,
robust, so it's got hundreds of feet, like
yeah,
couple of hundred feet. So that's radio, right? I mean,
yeah,
what's
yeah.
what's the easiest way to implement that?
In my head, I was thinking just just get a standard outdoor Wi-Fi antenna, but I don't know the distance. If 200 feet maybe be too far. I don't know. That's a good question.
No, but
Uh,
just without internet, prior to the internet, because I mean we'll do that later. But first, let's just get
yeah,
it so the operator can have a joystick right there. You're not gonna say you're out in the field wherever. You're not gonna have
yeah,
internet, right?
yeah. Well, in theory, you can still operate it on like a local Wi-Fi network,
Yeah, you
but
can do that. But say we
but
don't have that. We're minimal, and we don't want to,
yeah, yeah, because the antennas I was looking at previously were based on that. I call it LoRa, low range. LoRa.
Lauren.
Yeah, what's it called?
Long range note like Lauren.
Yeah. LoRa, long
Let's
range.
see, Lauren transmitter.
That was I think that's the what I had been using previously, and I don't and then but I had written some clunky code just myself to build the joystick previously.
Mm-hmm.
So I don't know if I went back with that same hardware, I could have it be a little faster. Um,
Like there's some YouTube. Do I build a powerful LoRa transmitter for long range RC? One that comes up right away.
Hello guys, welcome back to our channel and I know it's been a long time.
Um, yeah, whatever's the easiest route to implement. But take a look at this. I mean, I don't know, whatever. There's gonna be a lot of
yes.
but yeah, just something that's like on one side that's self-contained and super
Yeah.
simple that we
Yeah.
can take out. Because also you have to consider, okay, if we're gonna be given this to people to use, they got to be able to just grab the joystick and control it for one
Yeah.
on one side, and then
Yeah.
still, um, yeah. I mean, I think that would be like for the first build. I think we should go headless, and then I mean, of course, accommodate you can put a cab in there, but just go headless first, and
Yeah. Yeah.
that would be I think pretty cool.
Yeah.
Because a lot of times, I mean, the way it's the skid steer is used in practice, it's like I don't want to be in there. Like,
Right.
is it too
You're getting jerked around everywhere. Yeah.
that plus? I mean, it's a lot of just moving stuff around, and when you move stuff around, you got to get in and out all the time. Like you got to put blocks underneath things and things like that. So it's just much more comfortable to be outside and doing that kind of work.
Yeah.
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 hmm Let's see. So
I'm looking at the Bluetooth low energy thing, and it says from 30 feet to 330 feet, which is that's quite a range of. That's not saying much. I don't know, but
Let's see. So what's let's see. How much does
I was just leaning that way just because it was pre-built into some of the Arduino stuff, but those LoRa antennas are easy to get too.
I mean, is it gonna be? I, so this is Bluetooth.
Yeah, it's some sort of new standard for Bluetooth that for like watches
Well,
or
I
something.
mean, go on chat and ask if it's okay. Is this reliable for industrial grade? That's the question you want to. I mean, we're talking
Yeah,
like make it reliable so it's safety
right,
issues and all that. I
right.
don't think that Bluetooth cuts that. I
Yeah,
don't know. I haven't really specifically asked so much, but take a look. I mean, go with a system that it's actually industrial grade, like civilization grade engineering, not just like toy realm.
yeah,
Um,
yeah,
we
yeah,
definitely got to do that.
yeah. Okay, well that's yeah. I can get back at that. So there was a company called what was that name thing? This is where a lot of those device to device radios were coming from. Uh,
Yeah, yeah, Elaine. Hold on a second.
sure.
Yeah, yeah. Go ahead. I'm on another call. Yeah, what's up? Um, yeah. Okay, sorry about that.
Very good.
Um, yeah. So anyway, so take a look at. I think as the next step, take a look at what we can do for like true industrial grade, just for wireless control. And I think it's probably like the similar systems like you got in drones. So probably
Yeah,
a joystick
yeah,
like that. Um, so a good like ergonomic interface. There's joystick on the one side. We can think about okay, then if you do the vision part on it. I mean that's going to be some more hardware, but I think we should go with one that's like super simple, just the minimum basic set for
yeah,
the
yeah.
remote controller, and then we can say okay, well what do we need to do other things like the video, but I would say just do the simplest controller that then can interoperate with your solenoids.
Okay, yeah, yeah, yeah.
Do you have any solenoid valves that you can actually test out there, or
I ordered uh, the proportional valve, but I haven't ordered any solenoid valves yet. But
proportional valve is that's just manual or
it's oh shoot, what I did. Let me find that thing. It's I don't know if it's pulse width controlled, but it's it has a digital input. Let me see here.
And that's for open center, because we're open center, so we just got constant flow. So this thing, it doesn't require like a variable flow pump, does it?
No, it diverts on a percentage basis, 0 to 100% diverts it. Where did I put that thing?
Yeah, because that gets you some control. I don't think those are like truly like the ones that are really accurate are they actually got gears inside.
Right.
It's not that type. It's just a valve spool thing.
Yeah. Let me see. I made put too much stuff in here. Let's see here. Okay, I think I found it. There we go. Okay, I'm linking to it. There we go. I think the big benefit of one of these is that you have the soft start. You can when you push forward, it'll go from slowly build up to 100% instead of slamming open.
Oh yeah, okay. And it's just diverting the rest, right?
Yeah, so it just diverts the rest until you get to 100, and then it puts it all through.
How much is the XB Pro, the 900 HP RF module?
Oh, let's see.
Are these expensive? So that's what you're thinking for the proper distance that we need, right? And
yeah, because I think that's what I had gotten for the previous one we had built. And I think the lag was just my coding skills, because so I had to build it directly into Arduino at the time. Let's see. Yeah, those modules look like they're about $50 to $60. So you would need 2 of them. And then there's I think SparkFun has a Arduino shield you can just clip them right into. And at one time they had sold like a joystick like PCB with I think they stopped. I think it discontinued that.
Yeah, I'll have to figure out what it looks like. All right. Yeah, let's see. So let's specify like the signal part, like for the simplest controller part. So probably Arduino and whatever, just the RF modules. And let's take a look at the details of that, and then get around that. And I think what we should do is like put that into a part library and actually experiment with these workflows, just even designing the little joystick thing, for ergonomics and things like that. If you can buy like an off-the-shelf joystick.
It's funny. I was looking at what was it called? There's these things they sell that just like people clip into their cell phone, and it has joysticks on either side. Here, I got it here. This is one I saw. I call it Backbone. I didn't know, if the I don't know if that would be, because if you build a piece of software on the phone, will that automatically be compatible with it or not? I wasn't sure. And then Spark Fun has like it's like an interoperable connection thing called Quick, QWIIC, and you can have a little different modules like a thumb pad joystick thing, and they can daisy chain to each other. And I think in theory I could build a whole handheld joystick thing using just that standard they've got, the SparkFun deal has that they use.
Yeah, that sounds good. Let's see the proportional valve that you got. So you're talking about that's electronic.
You have to have a driver for it. I assume it's some sort of
like a mechanical driver. You're saying?
Let me see. Where was that?
Send a link to that.
Yeah, let me find it real quick here. Do the thing.
Hold on, let me see if someone's knocking on the door here.
Yeah. Okay, that was the. I just sent you the electronic. So you'd have to. You'd send a signal from an Arduino to that, and that would operate the electronic. I don't know if it's a solenoid, a proportional.
Yeah, Katrina, I'm on the phone. If you can just get that. Sorry.
There you go.
Yeah. That's the Burkhardt controller.
Yeah, so that'd be like in between the Arduino and the actual valve.
Huh.
Now, it seems like that's something we could.
How many GPMs is that there? Let's see what we got there. Is that
Oh, the
that's a per proportion? Okay, that's the controller. Let's see. Okay, that's cool. Gaming controller.
the valve itself, I think it's either 10 or 15 gallons per minute.
Mm-hmm, mm-hmm. Let's see. Okay. Yeah. So
I ordered
let's see.
I ordered a 20 gallon per minute one. I think it looks like.
Yeah, because for like 60 horsepower. I mean, if we got each of those pumps is going to be like 7 gallons per minute or so. 7 times 4 would be 28. They make them as big as 30, or probably need a couple. How much is one of those?
It was kind of a lot. Let me look here.
Holy cow. I mean, we can go just with a simple on-off stuff too, and turn them on one at a time.
Yeah, that's true.
So
It's $450.
holy cow.
But I was in my mind. I was thinking we use one for the
Startup?
or just you could tie them all through. I don't. Because what would the max gallons per minute need to be?
Well,
30.
yeah, I mean 30 for the entire vehicle, yeah. But
Yeah, so
like 7 at each wheel.
yeah, okay. If you had two. I was in my mind. I was thinking you could have 2 of them.
Yeah,
and something,
good.
and kind of have left and right side.
Mm-hmm, mm-hmm.
And then I think I had been playing around with the idea of having like the left side be tied in with the main arms, and then the right side tied in with the bucket.
Yeah.
So like if you're driving forward, you could adjust left and right without lifting the arms. So you wouldn't be using the arms at the same time you're using the wheels.
Yeah, I have to think about the strategy. But I mean, another way to do that is you just you got a divider, a divider valve that you just go and or just in series. Yeah, right. I mean, in series you can do the arms, and that's taken away from the wheels, but that's all right. Interesting.
Because if you had 2 of them, then you could have you could have real smooth tank control of the left and right. You could make turns with the radius, and you have varying see if because otherwise I think you'd be making you have to come complete stop, make a stationary turn.
Oh, why? Why?
Or if you didn't have the proportional valves,
typically, like what happens is though the wheels spin out, so that's your transmission kind of. That's your.
I see.
So it's no. I mean, you don't have to stop. I mean, the way skid steers are run, you run them pretty aggressive, and then you just that kind of level won't matter because the wheels spin out a lot.
I
especially
see.
if it's
Yeah.
especially if I mean if you're in any wet territory. But even on regular ground, I mean they spin out all the time. So
Yeah. Yeah. Okay.
yeah, I mean I think in the absolute simplest case, just simple on off is okay. I
Yeah.
would
Yeah.
say.
Yeah. I agree. I agree. I was kind of something interesting. I just wanted to, see if we could implement it kind of deal just as a,
Hmm.
but, yeah.
Yeah. SparkFun XB quick. Uh-huh. Okay. So I think, I mean, maybe as some of the next steps, um, I'll send you the stuff I got regarding the workflow for how you do the direct to FreeCAD without, you don't have to go to OpenSCAD because you do want to do it in, you don't want to be operating with the meshes, you want to be with the solids as much as possible too, though.
Yeah.
That's another issue. But let me see on my log, let me just get you a link or two because I did that for, okay, look at FreeCAD Plumbing Designer and, okay, you can read through that. I kind of describe a lot of the process there, but study that and maybe just start. I mean, convert your stuff that you got in the OpenSCAD stuff.
Yeah.
Start
Yeah.
working that into just direct FreeCAD solids.
Yeah. I think that should be straightforward. I
Yeah,
think.
it's. I mean, it's pretty straightforward. It's like
Yeah.
it sounds complicated, but once you do it, it's like, oh man, this is so cool.
Yeah.
Yeah, yeah,
It's amazing how far along FreeCAD has come.
yeah. And FreeCAD, I mean, it's premier for these kinds of workflows because although other things don't have direct programming access, they're not open
Yeah.
source, right? So,
Right. Yeah.
yeah. It's,
Hmm. Yeah. The other thing I was looking at was, having AI uh, exported plate file. The parts that need to be CNC or just having it automatically nest things.
oh yeah. So on one side, yeah, you can say, yeah, nested on a sheet. Yeah, exactly. So step one, just give me the DXFs and then give me the nested file. Yeah, absolutely. I mean, we can do so much with that. Yeah, we got to just get into that and do it to develop those workflows and just document them.
Yeah.
So in the summer we can actually run with it.
Yeah. Yeah.
Yeah, we want to do another torch table like with the 1-inch universal axis. That's the thing. So we prototyped that before, but yeah, I think right now it's time to just knock it out of the ballpark and make it actually work for production grade. Yeah,
Yeah.
and yeah.
Yeah. So it's interesting.
Yeah.
AI world. I don't know what's happening.
Yeah, no, crazy stuff happening with that. So what are the next steps? So work on the just the simple electronics for the controller, and then try to let's see, can you get it tested? You have those proportional valves, and if you can turn them on and control them, I mean, you can pretty much see that.
Yeah.
You can pretty much see and document that, right? So you got your controller and you've got the receivers on the valve sides. Can you put together a little test system for that?
Yeah. I think I can. But I haven't gotten the. I was going to get bidirectional solenoid valves. I didn't know how many gallons per minute the wheels would need or the arms.
Right. So, I mean, I think 10 GPM is a good standard to work with. So for any one pump, like if it's 15 horsepower, that's going to be like 7 gallons per minute or so.
Okay.
So that's what we have. If you're combining them, then you need 14 for each one. But if it's a single one on each, I guess we need the 10 gallons per minute. I mean, we could do that for like the first tries, like just the Power Cube with 2 engines. I mean, that's a good test, and we might have to scale those pieces of equipment up. But those 10 gallon per minute valves, they're like $100 on Surplus Center. At least they used to have them there.
Yeah. And it's like inflation, everything's going up. It's wild.
Oh yeah. Yeah.
Yeah. So okay. So 10 gallons.
10 gallon per minute.
Yeah.
Get a couple of those, and we can have a pretty functional system.
Yeah. Cause I think I could build out the whole. I don't know if I could bring up, the valves, ready to go, with just actuating them without actually pumping fluid through them. I don't know if I could do a whole setup with the pump and hydraulic system yet, but I at least have the valves operating kind of deal. And then have
I mean, if you make the lights light up on the valves with the joystick, I mean, that's, just look at, are you getting immediate feedback, immediate response and stuff like that. That would be a good test. So here we have
the distance test too.
Yeah, distance test and stuff like that. Around walls. Yeah. Okay, well that sounds good. So let's keep going with that and convert that stuff to FreeCAD so we can actually start getting the part libraries for your current geometry. Because I mean, your basic geometry, it's it's there. We just got to start refining it and actually put more components into that. But that's a great start.
Yeah.
Okay.
Sounds good.
All right, man. Well, good to catch up a little bit. And
it's been a while.
It's been a while. Yeah. So thanks, and keep going at it, and let me know as soon as you got any more progress there.
Yeah, I'll email you to get some stuff going.
Yeah, I see your log. I mean, I can follow it right there too. It's good. Glad you have that all documented there. Great. Okay, so we'll be in touch. See you soon, man.
All right. Take care. See you.
Okay. Bye-bye.